I hope that what I'm presenting here will be helpful in emphasizing or clarifying or maybe underscoring some of the points that have been made today. And there's been some exceptional points. It started out with John's comments this morning that I think really resonated with me, because he said that really the policy components of what you're all trying to achieve up here is to promote stewardship first and foremost, but also have government efficiency in the way things are administered, and then have that maintain industry competitiveness. And I couldn't have said it better. This is exactly the three components that we were trying to achieve in our habitat conservation plan. I don't want to spend a lot of time talking about the HCP process. I want to talk more about, I'll give you some context for why we did the HCP, a little bit about what it is, but mostly I want to talk, Rich asked me to really talk about some of the tools we use to build our riparian management strategy in the HCP, and also then to focus on how we constructed the adaptive management component for that. And what's been going on in the last 10 years since we've implemented the HCP in Montana. So I'll focus on that and end up a little bit with some of the lessons learned and some thoughts on what might be helpful for your endeavors up here. The HCP is really, it's very similar to what you've been talking about here within your legal context. The Habitat Conservation Plan is a process under the Endangered Species Act in the United States that allows landowners, agencies to exempt themselves from current endangered species regulations, exempt themselves and come up with another approach and mitigation measures that will support that approach. So it's really like an alternative plan, if you will, but it's on a large scale. And I wouldn't encourage anybody to go through that unless you really are hurting, like we were on the coast with spotted owl circles and with the bull trout in Montana. In 1993, when the bull trout was being proposed for listing and discussed, we started to survey for bull trout in our ownership and found out, to our surprise, that we were the largest private owner of occupied bull trout habitat in the world. We had ownership, we had bull trout spawning streams, migratory streams, everywhere from Montana all the way out to Washington State. And so this caused us to want to do something pretty, I guess, in view of some radical, but to actually sit down with the government and negotiate a plan that would allow us to continue to operate in these streams, to do business that we were doing business like we were doing business, but do it in a way that would promote conservation of the species or mitigate for any impacts we might have in occupied bull trout habitat. So our HCP is a 30-year agreement that we negotiated with the U.S. Fish and Wildlife Service and National Marine Fisheries Service, and we had several native trout species involved in it. The bull trout is, of course, first and foremost, but we had the West Slope cutthroat, Columbia River red-band trout, and then we also, when this plan was originally done, we had coastal areas where we had salmon and other coastal species involved in that. We've since traded out or sold some of those lands that were originally in the 1.6 million acre project area. This currently is being implemented on 400,000 hectares in western Montana, and that's on our ownership as well as some other timber companies that have purchased our land there, and we were able to transfer the incidental take permit that allows us to implement this plan onto those ownerships, so they're implementing our plan as well. The NFHCP is really a pretty comprehensive plan. It's got 53 different mitigation measures involved there under these topics, and I'm just going to focus on 2 of those right now for purposes of this discussion. But it is, as you can see, fairly comprehensive. It looks at everything from grazing to road construction practices and riparian legacy and restorations and other categories within the HCP. In your packet, I've given you a CD, and that CD it will have everything, lots and lots of information that goes well beyond what I'm going to be giving you today. So I would encourage you to take a look at it. This is, when you open it up, this is what you'll see. And you'll see in there that there are categories about implementation audits, our adaptive management components, documents, summary reports from our 5-year review, and summary reports from our 10-year review, which we completed we're in about year 13 of our HCP as we speak. That last category down there is a link. If you have your browser open when you open the CD, it will take you to the U.S. Fish and Wildlife Service's site, where the original HCP document is there, the environmental impact statement that was used to analyze the document back in the year 2000, and importantly will be the technical reports that we developed, peer-reviewed technical reports. There's 13 of them that we developed, my science team developed, to lay the groundwork for the HCP. A lot of what I'm going to be taking out today for this presentation comes out of what we call Tech Report 7, which was the riparian management strategy that was built on the modeling for wood recruitment, depletion, and such. So I will be pulling up some information, but you can find the actual source document by going to that link and pulling up Tech Report 7. Well, first and foremost, when we started down this path, and I've heard it said today, most important thing for us was to develop a strategy that worked for our ownership and our management, and basically sort of shrink wrap some of the science around our landscape and our management practices. And so we really attempted to do that, but we were faced with a paradigm. And when we started to negotiate with the U.S. Fish and Wildlife Service and the National Marine Fisheries Service on this, the forests, they were looking at basically the public land strategy that would have been in place on the Forest Service and the Bureau of Land Management. And those were very large buffers, 300-foot buffers on either side of the stream. 90 meters, would that be? I'll tell you, I'm trying to make those mental conversions here in my mind. We measure things in units like angstrom acres and barnyards per square furlong down in the United States. So you'll have to excuse me if I'm not quite conversant on the metrics, but those were very large no-touch buffers that were implemented on federal lands based on different science strategies. And so we basically, that was the paradigm that the government came to us with and said, well, you know, this is kind of what you're going to be measured against. So we really had to come up with an alternative. As Rick has talked about, we had to come up with an alternative that fit both a business and a biological imperative. Our approach was really kind of tailored to our settings in that we wanted to first analyze what did we have on our lands for riparian structure, and then how did that structure and how did that landscape relate to fish sensitivities. So we put a lot of effort on that and investment in that. We found that through that effort that we could focus on areas where large wood was a key factor, and that those buffer widths and management strategies really made a difference with regards to fish habitat and the trajectory of fish habitat health and recovery. We used models to simulate the wood recruitment process because the timeline, if you know, the timeline really sort of thwarts you. We didn't want to get in a situation, it was very difficult to say, well, we'll try this riparian strategy, but we'd have to wait years and years to find out if the wood recruitment really occurred, if the wood depletion really occurred, and if we found out we'd missed the mark, we basically made a large mistake out there for a long time. So we used the wood recruitment models to help us understand the consequences of different management paradigms out there and be able to hopefully reliably model those processes so that we could see ahead 30 years to see what would be likely to be there in the stream. And finally, to address the uncertainties, and there are uncertainties in any one of these kinds of things that we've talked about today, we developed an adaptive management process to really try to address these concerns, these leaps of faith, if you will, in different management practices, different approaches, different monitoring strategies. And so we used adaptive management to design that concept of sort of stating your objectives up front, stating your scientific investigations up front, and then launching various strategies at once simultaneously, but evaluating and identifying the ones that hit the mark. But basically trying multiple simultaneous experiments. We predefined triggers to guide that need for change, and then the adaptive management framework structured our discussions with the agencies when those 5- and 10-year reviews brought that information to the forefront. The first thing we did is go out and evaluate the condition and the structure of our riparian stands. To do this, we went out there and put in 640 riparian plots. These are basically cruise plots. This is in contrast with maybe some of the other remote sensing things we've heard today by Jay and others about LiDAR. And but we did this back in the mid-late 90s, and so we went out and did cruise plots. We structured the cruise plots around different trees per acre kinds of things and densities, and we used traditional mensurational characteristics to define that. This is a tool, a technique, and you might have seen this. I think I saw it in someone's presentation today, but it's the stand visualization system developed by Chad Oliver at the University of Washington. So with those densities and diameters that we'd had, we went from very high density, high diameter or large diameter stands, which we called T15s because they were thick. And then we had intermediate types in here, and then we had areas that had relatively lightly stocked but large diameters to lightly stocked small diameters. So this became the sort of currency, if you will, to model, map, and discuss our riparian stands during the course of building the HCP. And we developed different management scenarios for these, and we also modeled wood recruitment and depletion for those stands in riparian settings. And the bogey we were really targeting or at was what was really present in undisturbed streams. So we did some analysis of, we did some plots in areas on our land and on Forest Service land that had no visible history of harvest in order to understand what was out there in an unmanaged situation. And that was important for us to develop that as a baseline or a touchstone as we started to look at our managed stands and what they could and would recruit and deplete in the future. We also, this is another tool. I'm going to give you one of the approaches we used here. I've heard, I think Rich talked about the Rosgan method, very well known, used quite a bit. We grabbed onto Montgomery and Buffington stream classification system, which was done by David Montgomery at the University of Washington. And the reason why we liked this was because Montgomery and Buffington really looked at classifying the streams by how wood functioned in confining streams, as opposed to some of the areas as you go up where more boulders and rocks and such. Geomorphology defined the structure. And this is a complex slide here, but basically this is stream gradient as you get steeper. And this is kind of how Rosgan's classification schemes lined up against the Montgomery-Buffington scheme. And this plain bed forest pool riffle is probably one of the most important places for us in terms of stream classification, because those settings are more defined by coarse woody or large woody debris in terms of defining and recruiting and maintaining the stream structure. I'll give you an example. Here is a plain bed forest pool riffle set up in Fishtrap Creek, which is a bull trout migratory stream. This is one of the buoys that we pulled out of there in our surveys. And this is also an area where we've done some experimental wood placement and monitoring to see how that wood structure functions in the stream and how long it stays around. But that's an example of a very important habitat and structure type in our ownership. Another tool, in addition to the Montgomery Buffington stream classification, was was the channel migration zones. And now I am comparing and contrasting with information that Rich has given and Rick has described. We use channel migration zones because, as you know, channel migration zones are where the stream might be or have been at some point in time, but might go again. And so we, right now in Montana, the current riparian regulations really establish 50-foot or 15-meter buffers from the ordinary high water mark. And that doesn't necessarily capture the channel migration zones. So we felt that this is an area where our HCP needed to go beyond the current state regs in Montana in order to capture this very important component of fish habitat, which are areas, channels that might be active in the future, and make sure that we did a buffer strategy that incorporated those features. Here's some examples of the channel migration zones. I wanted to point this one out to you. It looks kind of like a normal stream, but you can also see how important wood is in this channel, in keeping this channel. This is what we call a high sensitivity channel migration zone. We had 5 different classes of channel migration zones based on size, degree of wood. We trained our foresters in how to recognize these in the field. In fact, their crews, they all have laminated keys that they carry out there so that they can identify and classify these. There's different prescriptions around these kinds of channel migration zones, and there's setbacks and things that they need to do with regards to their buffers. This one is a high sensitivity. This place in Squeezer Creek, which is in the Swan Valley, tributary of the Swan River, currently supports, is the highest density bull trout spawning stream documented in the Pacific Northwest. We found 141 reds within 1,000 feet of this, and 1,000-foot reach of this stream. And it maybe doesn't look like much, but if you go in there in October when the bull trout are in there spawning, it's quite a sight. But this is an example of how we were able to use the biological monitoring as well as the structural classification scheme to do the right thing in the right place. Here's the Swan River where Squeezer Creek comes in, and you can see the braided nature, the channel migration zones. Again, the kinds of things that normal forest practices rules in Montana would not compel us to do. And then finally, the other tool I wanted to bring is the RAIS model. And that's the Riparian Aquatic Interaction Simulator. RAIS was brought forward by Welty and et al., really developed by Weyerhaeuser on the coast. We used it quite a bit, and that in conjunction with the Forest Vegetation Simulator, we were able to then use this as a way to model wood recruitment and depletion rates in those riparian types that I mentioned earlier, those different structure types. I'll go into a little bit of our philosophy or our strategy in working with the Fish and Wildlife Service on this. But here are a number of assumptions that you have to have before you get into the RAIS model. And one of them is random direction of tree fall. Others are since there's large woody debris loading relative to unmanaged streams, recruitment, and how that comes in, how much of that you attribute to stand suppression mortality and bank erosion. And how big, when the tree falls in the stream, how much large woody debris does it actually contribute, and the depletion rates. So in every one of these, we took we brought in conservative factors. We doubled or used coastal figures, even though we were in inland forests, and I'll have some examples of that later, but you can see here, we pulled from the literature. But we used conservative just because we wanted to make sure, using the model outside of its geographic area of operation, that we were not going to write some checks we couldn't cash. This is an example of the RAIS results coming out. I'll just draw your attention to 2 or 3 things. These large areas here are basically the large diameter, high density areas. We looked at different management options, which had to do with everything from clear cutting to the stream to these options over here, which were no-cut 70-foot and 100-foot buffers, and no-cut 50-foot buffers. And so we looked at the pieces. These are the pieces of large woody debris that were recruited. That had to be 2 meters in length and at least 10 centimeters in size, and this is pieces per 1,000 feet of stream reach. So as you see in here, there's some areas you can see dramatic differences in 30 years on 10-foot wide channel types. You can see dramatic differences between no cut and harvest options. Nobody knows what's the right answer. I mean, this was a way for us to evaluate where we were coming in if we did different management scenarios. This isn't to say that this is where you necessarily need to be if this was excessive for fish or not. But what's important is in these areas up here, there were really no harvest opportunities because these were lightly stocked stands, small diameter stands to begin with. Most of our ownership is in this category here, so we were able to look quantitatively at what different structure options, whether we cut evenly between the buffer width, half and half distributed, or whether we concentrated the harvest and retention in the latter part of the buffer. So we're able to use this to kind of quantify and discuss what was necessary. The outcome for us and our strategy was that we had 15-meter buffers, 50-foot buffers on each side of the stream measured from the edge of the CMZ. This doesn't necessarily mean from the ordinary high water mark. It was from the CMZ. So we incorporated that. Where clear cutting was adjacent to the buffers, we then put a feathering zone, an additional 50 feet, 15-meter feathering zone on that. And if it was not needed if we were doing partial removals. Most of our harvesting in Montana is partial cut. So we do employ this, but we do it on areas where maybe we've got a more intensive harvest going on outside the buffer. The high sensitivity CMZs, which are for instance, those plain bed force pool channel types, where we are in bull trout spawning areas, so we shrink wrap that around the high priority watersheds where bull trout and those listed species are actually there. No removal of trees in the CMZ and in the adjacent buffer. So that's our most restrictive prescription, and based on how we built that, we don't really there's not really much of a debatable thing. The fish are there, the structure's there, and so that's a good place for us to employ retention. For other channel types and lower sensitivity CMZs, we use a variety of buffer prescriptions, all discussed there. You can see those on the CD. But we must retain at least 217 trees per hectare. That's partial cut in those buffers. Now that for us, I mean, the rule is 88 trees per acre, so that comes out to 217 trees per hectare. And the removal that we can take are only trees over 20 centimeters in size. So we retain the bank edge trees, of course, and favor harvest towards the outer half of the buffer. And the trees retained must be representative of the size and species of the pre-harvest stand. So those are a couple of other. The RAIS model, we looked at it, we developed an adaptive management trigger around that. So we conducted basic research to validate that. We reran the RAIS model on the stands that we had initially modeled and harvested in at year 10 with our improved assumptions. And the trigger was if the original model forecast over-predicted large woody recruitment by 20%, that was a reopener. We had to go in and redo our look at our prescriptions. So let me explain how that's come through. So that adaptive management, that was a trigger, but it was within the context of this adaptive management framework. And I'll just highlight quickly, we have our overall conservation of fish objectives. We have the basic biological goals. We have specific habitat objectives. Then we have those management actions, which have to do everything from road construction to riparian design. And then under those, we have performance metrics. But then our monitoring and our metrics are wrapped around both implementation and effectiveness of the prescriptions. So we look at, did we implement it properly and did it work? And then this one is a very important part in here. It's called biological relevance and causal linkage. This little piece of the flow chart is very important because, as you know, you can monitor a stream, come up with a warming of 1/10 of a degree. in a bull trout stream. However, if we trip a trigger just because we're able to measure that change, that physical change, does it really have a biological relevance to the target species? And is it caused by the management of the HCP, by our management practices? We might have a damage to the structure of the stream because of ice, anchor ice or something, but that's not necessarily a problem, or a flood is not necessarily a cause of it, can be traced back to the HCP. So this was a very important piece that kept everybody thinking about the objectives, the main biological objectives. We also have then, under those, if we do trip a trigger, we can have predefined mandatory management responses or collaborative management responses that we can work with the service. This is quickly on the RAIS, on the RAIS model somebody's talked about today. We definitely did in the 10-year monitoring, we definitely show that direction of tree fall. There is a downslope fall bias on less than 40% slopes. You see the wide range of variability there between fall. But as we get into the steeper hill slopes, you see that's a narrow range in there, more trees falling, definitely getting more trees recruited into the stream as a result of that slope. Large wood depletion rates ended up being lower than we modeled. We thought the wood would disappear sooner because we were using, we based it on 2% depletion rates based on research from Southeast Alaska, but it came out to be 1.6% in our monitoring. So basically the adaptive management trigger was not tripped. The validation studies confirmed that our original assumptions were conservative, and we were able to move on. This may be relevant for you folks here that have a little more of the clear cutting next to the riparian area. But in the Cascades, where we do the same thing, we have buffers there. Our buffers are larger in the Cascades because I designed them to accommodate spotted owls, not just fish. So we look at, on fish-bearing streams, 200-foot buffers, 60, 90 meters. But those are there because not for necessarily fish habitat protection, but because owls are using those riparian zones. Well, we wanted to look at the wind throw, and so we did a study to look at that in our 15-year review, our 10-year review of the Cascades HCP, which has been going now for 15 years. And we did find that the prescriptions were effective, that we did have some wind throw, but it was on the outer edge of the buffer, and the wind firmness of those buffers has been proven out. The lessons learned that we've had here, I'll summarize with this. That forest health of riparian buffers is a concern. I've heard it expressed today. Riparian areas do burn, and we've had some doozies. 2003, 2007 in Montana burned right through some of our buffers. Interestingly enough, we had temperature monitoring tidbits and stuff implemented because of the HCP, and we were able to actually evaluate the impacts of that burn the day it burned, and the elevation in temperature and the before and after impacts on fish. That reports on the CD as well. Might be interesting to you. Validation studies and effectiveness are essential. I've heard it expressed today. I'm sorry, it was the Tri-Creeks experimental project. It did look at paired study design. We have implemented a BACI design, before-after control impact sort of structure, to our adaptive management monitoring areas, so that we were able to get monitoring going on before treatments were imposed and then after. The models are essential, especially, as I said, when dealing with in-stream parameters. And because of the response lag times, we really had to depend on modeling to help visualize what's going to happen under different management prescriptions in 30 years, so we didn't find out later that we'd taken too much or that we were recruiting too little. We have a predefined framework for adaptive management, that flow chart I gave you, so that the science that we generate and that we publish and we share with the service at 5-year intervals is generated. It's run through that. It's predestined. We have the hypotheses and the triggers identified. We collaboratively, mostly on our ticket, but we do work with others to gather that information And then we use that in the periodic reviews to evaluate the effectiveness and the implementation of those management prescriptions. And we have periodic set reviews, which I mentioned earlier. In our HCP over 30 years, we have 5- and 10-year major reviews, and we've just been through both a 5- and a 10-year review on this native fish HCP. We've been through a 5-, 10-, and 15-year review on our Cascades HCP, which addresses 315 vertebrate species, including terrestrials. So